Hello everyone, let's try to solve a very tricky problem today. In this problem, we are given an array of n words and we are allowed to do a swap operation between any two characters of any two words in the array. Please note that we could choose the same word and swap two different characters within themselves. And we could do this operation any number of times. And we have to find the maximum number of palindromes that we can form in the words array after repeating such operations. Let's take a look at the examples given. In the first example, we'll first swap A and B from these two words. So this will now become 4 B's and the other ones will be 2 A's. So all the words are palindrome. So in this case, the output will be 3. In the second example, we'll swap B and A from these two words. So this will now become 2 B's. So this is a palindrome. And this will now become AAC. And if we swap A and C at these two positions, this will now become ACA. So this is also a palindrome. So both the words can become a palindrome and the answer is 2. Let's try to come up with an intuitive solution for this. Let's suppose these are the three words given to us in the array. For any given word, to form a palindrome, we first have to make sure that the end characters are the same. And if they are same, we move towards the middle and the second last characters have to be the same. We continue to do this in both the directions till we reach the middle character in the case of an odd length word. In this case, we don't have to compare it with anything else and this will result in a valid palindrome. And in the case of an even length word, the middle character will not exist and this will be a valid palindrome. So the first property that we can use to our advantage is that we can swap any two characters from any two positions in all the given words. So since we have an A over here, probably it makes sense to swap it with any character that has an A. So we could swap it with this. So this will now become D and this will become A. And when we look at this word, we see that it has all the necessary characters to form a valid palindrome. But we only have to swap these two positions and the resultant string will be a palindrome. Now let's take a look at this smaller example. We see that the first word has the characters A, B and C and D. And similarly, the second word also has the same characters D, A, C, B in a different order. So let's try to swap them to make a valid palindrome for both these words. Since we have an A over here, we need an A over here too. So we'll swap with this. So this will now become a D and this will become an A. Similarly, we have a B over here. So we need a B over here. So we'll swap this with this character. This will now become a B and this will now become a C. So we see that this word is now completely a correct palindrome. And for our second word, if we swap these two positions, this will now become a valid palindrome. So one key observation that you can make is that the ordering of these letters do not really matter. And since we are allowed to swap any two positions from any two given words or even the same word, we only have to verify that the correct number of pairs exists for all the words. So what this basically means is that we do not care which characters exists at any given word. We can collect all these characters from all the given words and then we can try to form the most number of valid palindromes. For example, we'll use these two A's. So we'll place them over here. Then we'll use these two B's and place them over here. So our first word is now a valid palindrome. And now we'll use these two C's and place them over here. And similarly, we'll use these two T's and place them over here. So these two are valid palindromes now. Hence, we can go through all the words in any given order and then store the occurrence of each character in a hash map. And then we'll use this hash map to form the most number of valid palindromes. Let's try to see some other properties that will be helpful to solving this problem. Let's say this is the hash map that we have for all the characters in the array. And we have these three words, one with a length of 6, length of 5, and length of 3. And using this hash map, which word do you think will be the most easy to make a valid palindrome? So let's try to use all these 6 A's in the first word to make them a valid palindrome. So we see that this is now a valid palindrome, but all the remaining characters have occurred only once. So we cannot use any pair of them to make a valid palindrome for both these words. So in this case, we were only able to make one valid palindrome. Now let's try to consider the case when we try to make the smallest word into a valid palindrome. We'll use two A's at the first and the last position over here. And for a middle position, we don't necessarily have to use an A, we'll use a B. So we'll still have 4 A's, which is like 2 pairs of A's that we can use to form more palindromes somewhere else. So we'll now use these 2 pairs on the second word. And for the middle position, we'll use any other character C. And for our third word, we don't have any valid pair left. So we have only formed 2 valid palindromes in this case. So probably you can see the intuition behind this, that it makes much more sense to try to form smaller valid palindromes. In this way, probably we'll have more probability of making more palindromes. If we start from the lengthier words, there might even be case that we won't be able to form even one single valid palindrome. For example, if there were 4 A's, then we would not be able to make even one single valid palindrome. So it always makes sense to start from the smaller words. And we could try to use all our pairs greedily to make the maximum number of valid palindromes. And once we don't have any pair remaining, in that case, we won't be able to continue anymore. Let's try to look at the final property that will make our solution very simple. When we are trying to make a valid palindrome starting from the shortest word, do we really care whether we add 2 A's over here or 2 B's over here or 2 C's over here? In fact, we are free to choose any of them if they are from a valid pair. So for example, we have used these 2 C's. So the number of C's remaining will be 1. So we don't have a pair of C anymore. So we cannot use C over here anymore. But we still have 4 pairs of A since we have 9 A's and 3 pairs of B's. It does not matter what we choose over here. We can place B and A in any order. In fact, we don't even care what is the character. We are only concerned if a valid pair exists or not. So for this example, for A, we can consider that we have 4 pairs. For B, we can consider that we have 3 pairs. For C, we can consider that we have 1 pairs. And D, we can consider that we have 0 pairs. And in fact, combining all of the pairs that we have, we can just assume that we have 8 pairs of A. And using these 8 pairs, we'll try to form a valid palindrome starting from the shortest word. So we'll use 1 pair over here and decrement the count of the number of pairs. We'll use 2 pairs over here and decrement the count by 2. Over here, we'll use 3 pairs and decrement the count by 3. And as long as we have pairs remaining, we'll continue to make more valid palindromes. Please note that for each word, we only need its length divided by 2 number of pairs, because for any odd position, we are free to put any other character over there. We don't need a pair to put over there. For instance, this can be B or C or anything else. Hence, to solve this, we'll first calculate the number of pairs that we have. And then for each word, we'll calculate its length and store it in an array. And then we'll sort the lengths in ascending order. And then we'll start from the shortest length and try to form a valid palindrome as long as we can. The time complexity of this solution would be O of n log n, because we have to sort the length of the words in ascending order. And the space complexity would be O of n, because we have to store the lengths of the words. Let's try to implement our solution. The first thing that we have to do store the count of each word that we see in that array. So we'll keep a hash map for that. And now we'll go through each word in the array. And for each word, we'll go through each character and increment the count of its frequency by 1. And now we have to count the number of pairs. For that, we'll just use the frequency of each character and divide it by 2. And then we'll have to find the sum of frequency divided by 2 for each of the 26 characters. So I'm going through my hash map for all the characters. I'm just ignoring the character because I don't need it. I'm only concerned with the frequency. So I'm dividing this frequency by 2. This will give me the number of pairs for that character. And this part over here will result in an array which will have the number of pairs for each character. And finally, we are going to sum that array. So this will result in the number of pairs that we have for all the characters. And now we have to sort the length of the words. Over here, I'm going through each word in the array. And for each word, I'm just transforming it to its length. And I'm collecting it in this array. And finally, I'm just sorting this in ascending order. So this array will contain all the lengths in ascending order. Now let's initialize our result to be 0. Now we'll go through each length of word in ascending order. And for that word, the number of pairs that will be needed will be its length divided by 2. We'll subtract this from the number of pairs that we have. And if our current pair is still greater than or equal to 0, it means that we were able to form the pairs needed sufficiently. So in that case, we'll increment our result by 1. We could have also written this by checking if our current number of pairs is greater than the number of pairs needed. In that case, we would then subtract the number of pairs needed and increment our result by 1. Otherwise, we could directly return our answer from here. And once we are done forming all the possible palindromes, we can return our result. We are now done with our solution. If this video was helpful, please show some love by liking this video and subscribing to the channel. If you have any doubts or concerns regarding this solution, please mention in the comments. Thank you for watching and see you soon.